Production and factory settings bring their own set of hurdles for wireless connections. Harsh conditions, both indoors and out, create a daunting task for engineers to work through. Now let me tell you, those engineers ain't looking to back down from a challenge like this, no sir. This here's where we gather round to tackle them hurdles, swap thoughts, and lend a hand. Welcome to the Industrial Wi-Fi Shop with your hosts, Scott and Jeremy.
Welcome, everybody. This is the Industrial Wi-Fi Shop, and we are going to have some fun today. I've got Justin and Danny from Phoenix Contact, and we're going to talk about wireless power transfer, wireless I/O, data transfer with power. It's going to be fun stuff. But first, we got a couple things we got to get through. Number one, we have two winners for our CWIDP guide giveaway. I'm really excited. So our winner from IT, and guys, if I mangle names, I do apologize because sometimes I just cannot pronounce people's names properly. Our IT winner is Phil LaFontaine from Minneapolis-St. Paul area up in Minnesota, and our OT winner is James Mifsud. I think I'm pronouncing that right, Mifsud, M-I-F-S-U-D, all the way from Brisbane, Australia. So we're getting down under, so people around the world are actually listening to this show, and that's pretty incredible when you think about, just this kind of redneck at the beach at North Carolina having fun talking about wireless stuff in industry, and there are people on the other side of the planet who actually listen to the show. So that's really cool, guys. I will email you and get up with you and get shipping information and get these books out to you soon. Congratulations. Pretty excited about that. And we're also kicking off another giveaway. Jeremy, if you want to throw out the details for this one, sir.
So I recently got a copy of the Wi-Fi Explorer Pro 3 Definitive User Guide from Nigel Bowdenand and Adrian Granados. And I've been really enjoying it. And so I thought we would do kind of the same thing. So I have purchased 2 copies of the book, and so we'll do kind of the same thing. Scott put together a Google form that'll be in the show notes, and we'll do one person from IT and one person from OT. But wait, there's more. I happened to get Adrian's cell phone last year at WLPC when we shared a lift to the airport, so I abused that privilege, and I asked him if he'd be willing to possibly donate some licenses. So along with that, we have a license for Wi-Fi Explorer Pro 3 that we'll be able to get for each of the winners. Unless, of course, if you've already got it, then that's one of the questions in the form. And then we'll kindly ask that you let us pass that on to another person. So that's going to be pretty exciting. And then, just as kind of an aside, if you're curious about Wi-Fi Explorer 3, if you haven't used it, it's an awesome Wi-Fi measurement tool that helps you kind of visualize the 802.11 environment. You can also do Zigbee and what's the other thing? You can capture some other stuff along with, actually that's AirTool, I apologize. But Keith Parsons had those guys on Heavy Wireless episode 45, and
that was a good episode.
Yeah, it was awesome. They do kind of a deep dive in like where the history of the tool came from, why they decided to write a book, all that kind of stuff. And so we'll put that in the show notes too. It's about 30 minutes, but it's jam-packed with information. It was pretty good. And then one other thing that was pretty cool that was announced at WLPC is that if you're the proud owner of an Osseum Nomad like myself, that's the device that was developed by Osseum for Hamina. That's their Wi-Fi measurement device, similar to like a Sidekick or a Cytos Wave. The IntuityBits team, so Adrian, integrated that into AirTool 2, so you can capture up to 4 separate channels. It works in 2.4, 5 gigahertz, and 6 gigahertz. This is where the note is, and that captures. You can also do Zigbee and BLE capture with AirTool if you have the appropriate dongles for that, and it's dirt cheap. I mean, it's like $30, and it more than pays for itself. So we'll put some links to that information to you, and I just think it's pretty awesome that vendors are making their tools open for other people to use. That collaborative nature, and it makes all of our lives easier. So thanks, Adrian, and we'll put that out in the notes.
That's a really big deal when vendors are starting to cross connect like that, and that really does make life easier for the rest of us. And to be honest with you, it makes their product look a little more attractive too, because we know we can use it with other tools that we already have or are planning on getting. Kudos to those guys. Upcoming, we've got some events coming up. WICO, we've got two events coming up WICO wise here in the U.S. May 14th in Chapel Hill, North Carolina, at the Botanical Gardens. We have another WICO event coming up. I will actually be at this one. I'll be presenting on fun with spectrum analysis, and I'll be going over some of the fun recordings and kind of the extreme things that I have seen out in the field that just obliterate the spectrum, which is awesome. And then on May 29th in Nashville, it'll be another Nashville, Tennessee, here in the States. It'll be another WICO event. And Jeremy, you will be at that one, correct, sir?
Yep, that's right. And hopefully we're looking at doing kind of like we did in the OT space at WLPC, setting up a curb demo and showing off some of the tools that the company I work for has built that allows you to do visualization and kind of basically system validation on it. And then maybe some other stuff, depends on what kind of goodies I can get together.
That's going to be awesome. That's good times. The WICO events are great. They're low cost, typically single day. I know over in Europe they've had some 2-day events, but they're lower cost and more localized. So it's easier for those who can't afford to go to the big conferences to get out there and get some kind of Con Ed action going on, and see and learn and meet more people in the wireless community in general. WICO is awesome. If you get the chance to go to a WICO event, I do recommend it. If there is no WICO in your area, then maybe you should look at joining the group and seeing if you can't start a WICO event yourself. They're really open with that, and that's kind of the whole point, is WICO is the wireless community. Let's see, our last kind of event we want to talk about a second is this is an OT event. This is a relatively new event. I think this is year 2 for it. Is that right, Jeremy? For OT SCADACon. And it has been put together by the automation ladies. What all we into on that one there, Jeremy?
So it's kind of a young conference, right? So it's in its second year, and it looks like they said they had 50 attendees last year, and it looks like they're trying to double this year, and it's in July in Houston, so the 23rd through the 25th. So you get to wear your cargo shorts. It's probably going to be hot. I used to hate cargo shorts, and then I just gave up and said I need the utility. I don't mind them. But they're covering, I mean, just kind of the highlights. So they're covering PLCs and IO, HMI, machine safety, machine vision, robots, cobots, DCS, OT cybersecurity. I mean, there's a ton of stuff there. So it looks like a really informative gathering. And it's, also with these kind of conferences, it's a great way to meet people in your same kind of field of study or your field of work. And I just thought it was like really cool. So I asked Scott if he minded if I put a plug in for it. So if you're OT curious, you can get a broad feel for what what we do in operational technology. And if you're in OT already and you're the Swiss Army knife person for your company, it's a great way to deepen your knowledge about some of the other systems that you might have to touch. So, especially for the wireless people, it's important to understand kind of what you're allowing to talk back and forth.
Yeah, and I've actually caught a couple of episodes from the automation ladies on their podcast, because they do live broadcasts on LinkedIn. I'll be sure to link that in the show notes as well. If you get a chance to catch them, I recommend it. It's always great content from a fun group of ladies.
I think it's a very reasonably priced conference too. I mean, it didn't look prohibitively expensive to talk your boss into paying for it.
Well, that's always a bonus, right? Is being able to talk your boss into paying for it. All right, well, awesome. So, let's get started for the meat and potatoes of what we're talking about today. Wireless power transfer, I didn't even know was a thing until not too terribly long ago. Justin, who's one of our guests today, he and I have been friends for quite a while, and sometimes, I just kind of run across things, and so I'll ask him about it. and it led to other conversations. And so today with us, we have Justin and Danny from Phoenix Contact. And I tell you what, I'll give you guys a minute here to tell everybody about yourselves. And those longtime listeners, you may recognize Justin from episode 1. He was the very first person to come and take pity on me and hang out for the first episode of the show. So take it away,
They beat
Justin.
me to it.
Yeah, thanks, guys. So again, my name is Justin Shade, Phoenix Contact. My role there is it's a mouthful now, but it's a business development application engineer for automation. And what that basically means is I get to go help people solve problems using automation products. And one of those products in my responsibility is the wireless portfolio from Phoenix Contact, which is near and dear to my heart. I was the product manager for 10 years before I changed roles and went in the field to start selling solutions. I'm homegrown Phoenix Contact. They'll be going on 19 years this year.
Wow.
So when I been there since I came out of college. So it's been a fun ride so far.
Wow, you're old.
I am old. I lost my hair, started growing my face instead of my head. Yep. So
I feel you on that.
when I moved on to the field to do some sales, I passed the torch on to Danny, and Danny, I'll let you go ahead and introduce yourself.
Awesome. Thanks, Justin. Yeah, so I'm Danny Walters. I'm the product marketing specialist or product manager for all wireless products at Phoenix Contact, as well as some of our outdoor PoE solutions. But yeah, I actually kind of come from a similar background as Justin. I've only been at Phoenix for going on 7 years now, but he and I both did the same apprentice program with the company and spent time in our technical service group supporting products. So I've got a background with automation, but now these days I'm focusing all on wireless. So I get to be involved with everything from Wi-Fi to cellular and everything in between, like this contactless power and data products. So it's always a fun time.
Awesome. Well, thanks for coming on the show, guys, and hanging out with us. When researching and everything for this episode, I came in with some preconceptions on what Nearfi was, and then I realized after looking up some stuff that I was confusing Nearfi with NFC. And Nearfi is completely not NFC. So for those not familiar, NFC, near field communication, it's what people use for phone-to-phone communication when you just tap the back and transfer a file, or you have a card with a chip in it and you just tap a reader so you can pay for something and whatnot. That's NFC. That's near field communications. Nearfi is not NFC. Nearfi is a whole different animal here. So when looking up the definitions, really, it's essentially a contactless, easy for you to say, right? Technology for real-time transmission of power and data across short distances, typically a few centimeters. And so the actual wireless transfer of power, to me, is fascinating. That's some straight up Nikolai Tesla type stuff, right? So, is Phoenix building giant towers out in the middle of a field trying to wirelessly, launch power into other places? No, they've developed a cool little device that can wirelessly transfer power. Now, so I've got like one of those wireless chargers for my phone. You set it in the cradle and it just transfers that way, but that actually has to have physical contact, right? This does not. So I really want to kind of get into, what hardware does it take for this to make this work? And then like, how does it work? Because we are, and again, correct me if I'm wrong, guys, we're transferring power wirelessly, but at the same time, also transferring data, correct?
That's correct.
Okay, so give us the third grader explanation of what we're talking about here and how that kind of works.
Yeah, absolutely. I would say the easiest way to explain it, funnily enough, would be to compare it to NFC. Tap to pay. When I explain Nearfi to people, I will regularly reference the NFC and the wireless charging of your phone, because that's the even though some of the underlying technology may technically be different, it works as a good analogy. It's something people can wrap their minds around. Everybody understands. Hey, you put your phone on a charging mat, it's going to wirelessly transfer power. You're going to wirelessly, power your phone. People understand, hey, if I'm at the grocery store, I can tap to pay. I'm passing a bit of data from my phone to that point of sale terminal, we all kind of understand that conceptually. So a NearFi can be kind of viewed like your phone in that regard, just a scaled up industrial version of that. So instead of being a millimeter or two of distance between the phone and the coil in your phone and the coil in that charging pad, NearFi you have a distance of about a centimeter to where you can do that power transfer. So it's very much the same sort of thing, to where you've got a coil that's going to have electricity running through it, generating a magnetic field, and then you'll have another coil that is having that current be induced through that coil because of the magnetic field from one side of the NearFi couplers. So
Okay, so that's really cool. So it's magnetic field power transfer. So how do you keep that from interfering with data transfer? Is it just a specific frequency, or what are we talking about here?
yeah, as far as I understand it's just going to be different frequencies. So the data transfer is going to be up at around 60 gigahertz as far as the frequency goes. The power transfer is much, much lower. I think it's down to the kilohertz range.
Okay, well, yeah. So then there's really no worries at all of any sort of EMI affecting data transfer. Okay,
Correct.
I was curious about that. But when it's that far of a spectrum difference, that's cool, man. What kind of data speeds are we looking at?
Yeah, so with NearFi, you're looking at about 100 megabits full duplex. So yeah,
Full duplex.
Yes, sir.
Okay.
Full duplex. Yeah, so there are technically two. They technically do use two different channels during that communication, so you can get your transmit and receive. At the
But if you're up in the 60 gigahertz range, and you're looking at that short of a distance, what my gosh, you're really not going to see it from very far away anyway, so you don't have to worry about stepping on anything else. Because I know there's like some wireless monitors and whatnot that use 60 gigahertz for video transfer.
Okay.
But again, that's also very short range. But that's really cool.
So with NearFi, I mean, you're looking at about a centimeter distance for the power transfer, and then about 10 centimeters for the data transfer.
Okay.
So you're using different frequencies than most every other wireless device that's out there, and then even with that, the distances that you're transmitting are very, very short. There's not much range at all.
I realize they work in conjunction, but do you have to? Is there only like one model, so where like you get power and data, or what if you only need like data transfer, or if you only need power? Are there options for that?
There are, yeah. So when you look at the portfolio of products that Phoenix Contact offers, there are power only, data only, and then power and data versions. So you have options.
What how much juice are we looking to be able to pass through this? I mean, I don't see it to be like 1.21 gigawatt. I don't think you're going to plug it in and into a DeLorean and be able to travel through time. But what kind of power are we talking about pushing across these things?
Yeah, so between a pair of NearFi couplers, you're looking at about 50 watts of power across that distance. So there is a flavor of NearFi coupler that allows you to have two pairs wired in parallel, that then will allow you to do two isolated 50-watt voltages, or you can combine those onto the same cable and have 100 watts effectively be transferred. But when you look at individual pairs of NearFi couplers, you're only ever getting 50 watts over the air.
Okay. We got this 50 watts of power. How are you getting that to the devices on the other side of that?
Yeah, so the NearFi couplers, they are square type cube devices. They can fit in the palm of your hand, and on those devices they have M12 connectors.
Okay.
And so you'll have a base coupler and a remote coupler. So if we're looking at the power and data transfer version of NearFi, that base is going to have a power input connector, and then it's also going to have an M12 Ethernet connector on it, because you're going to do both the power and the data. That base coupler will transmit that power and that data wirelessly to the remote coupler. And then that remote coupler, the M12 connectors on it will be output connectors. So you'll have a M12 power output connector, and then the other M12 connector will be your data connector, where you'd connect a M12 Ethernet cable. So that physical connector, that's how you're getting your power to your end device. So on the other end of that cable, you'll connect it to a 24-volt power bus of terminal blocks, or maybe some.
Okay. Okay. All right. That's something else I was going to ask is, what typically do you see on the other end of that you're actually powering through that?
Yeah, so you can go two different directions. When you have an M12 cable, you can do either a one end be terminated with M12 connector, and the other end being what we'll call flying leads, where you've got the bare wires, and in that instance, you're actually terminating the positive and negative, 24-volt wires on a bus of terminal blocks, or maybe into a specific device. You can also have versions of that cable where their M12 connectors are terminated on both ends. So the versions where if you're going to have a cable be terminated on both ends, typically you're going to land the other end of that cable on like a remote IO block.
Okay.
To whereas if you have the flying leads, yeah, then you're landing those wires on maybe a row of terminal blocks for your power bus, and then you can have all sorts of different devices that are connected to that power bus of terminal blocks, or you could just land those flying leads, those bare wires on a specific, on just an individual device. So, whatever, anything that can be powered by 50 watts, you can use.
So conceivably, you could be charging batteries and whatnot.
Small batteries, yeah.
I mean, nothing crazy huge, but
right. And that is an important distinction to make. You're not gonna be charging the battery of a AGV or an AMR, one of those robots that's driving around a factory. It's not going to be practical. If you have a small one and you give it long enough, you'll charge the battery, but that's not quite going to be practical for most applications.
And you said earlier that you could kind of do like a pair of them to get 100 watts. Is there anything that would prevent you from maybe taking like 2 independent sets of those and kind of running them separately in parallel to increase that ability?
Yeah, so the way it works is basically in there's a certain model of these near-fi couplers that actually allows you to take that power output from one of the remotes and you wire it into this special remote coupler. And on the inside, there's just circuitry that combines those 250 watt voltages onto just 2 different sets of pins in the cable, or they combine it in series, and so you get 100 watts across the same 2 pairs of wires in a cable. So you are limited just by physical circuitry in those remote couplers. So you cannot do 200 watts or 400 watts.
And then this is an emotional pain point for me. And if you don't know it off the top of your head, that's fine. But what's the coding on the M12 cables? Do you know, or does it vary?
Is it
is it like a 5-pin, or is it like an M12X coded and then you break it out or something like that?
So it depends on the model. Some of the model that allows you to wire them up in parallel, that's a newer set of couplers that we put out. Those are L-coded.
L-coded, yeah.
First generation is going to be A-coded, and I think they're A-coded. Yeah.
Okay. Yeah, the X-coded are the ones that's like you guard them with your life because they're hard to track down when you need them.
Now that's going to be for the power. The data connector, I'd have to look. It may be X-coded as well, but I'd have to verify that.
I was reading through some of the documentation, and it did say that these are already available over in Europe and they're being used over there, but they are currently in the final stages of UL's testing here in the States. Man, when these when these get released in the States, that's going to be a pretty cool tool in the old toolbox there for giving options for a lot of different things. So before we get into use cases, I really wanted to understand the safety that's involved with this, right? So industry and manufacturing, it's all about the culture of safety and whatnot. That it's hammered into you from every direction, from safety training to PPE to how to pick things up properly, for God's sakes. So how safe are these guys in use and just kind of that genre? I mean, like if you get too close, is it going to arc flash you?
Sure. I don't believe so. No, I've not heard of any instances where somebody got too close to these things and it had some big spark or anything like that. So I'd say the risk of that is going to be very low of that sort of thing being an issue. The nice thing about the industrial applications is the machines and robots that these things are going on are going to prevent you from by their nature, going to prevent you from getting close while these things are transferring power.
That's true. That's absolutely true.
You think of like a robotic arm, for example, that's doing this. it's going to be very difficult for you to get close to that near-fi coupler on that robotic arm while it's powered up. I mean, you're going to have to jump over a light curtain or find some way to violate the safety barriers and light curtains and that sort of thing to even
by then all
couplers.
manner of e-stops have tripped and you've stopped whatever's going on and someone's getting yelled at. So
absolutely, power gets cut and whatnot. I do want to make one point of clarification about the availability in the U.S. It's FCC that's being worked through, not U.S.
Okay.
That's fairly
I misunderstood.
battened up and ready to go there, but it's the FCC portion that's currently being worked through. But
okay.
But yes, it is. They are currently available in Europe, and we are very excited for being able to release those in the U.S. So
I was going to say, how widely deployed are these currently in Europe?
That I'm not sure. I'm not sure. I do know that these are the only devices of their type that can transmit power and Ethernet data at the same time. So they do have a competitive edge in that space. Other devices that I've seen are going to transmit I/O signals. There's some I/O link type devices out there. So,
and the other,
you bring up I/O link. What all protocols can pass over this?
Yeah, so it's going to be any Ethernet-based protocol. So these are transparent to the network. There's no MAC addresses, no IP. They are literally just passing bits, bits and bytes, transparent.
So 100% transparent, doesn't matter, as long as it's Ethernet-based, doesn't care.
Absolutely. These are literally, you can think of these as a cable replacement device or a connector replacement device, maybe to be more accurate. So
okay, no, that's interesting. That's cool, man. A lot of times when you see kind of niche devices like this, they tend to be protocol specific, and you'll have to get like some kind of converter or whatever in order to get full and proper usage out of them. So all that being said, what are some of the use cases that you guys are seeing for these devices? It's killing me. Wireless transfer of power. I mean, like I said, it's a whole Nikolai Tesla thing. So it's
they're very cool devices. It's one of the devices I'm most interested in when I look at the products that I've got in my bucket for sure. But when you think about applications, though, I think it's good to kind of take a step back and ask yourself, okay, what are these replacing? These are replacing pluggable connectors. So applications where you've got pluggable connectors that are transmitting power and data, these near-fi couplers are going to be a good candidate to replace those physical connections and work in those applications. These near-fi couplers do also tolerate rotation. They've been officially tested up to 1400 RPMs.
Holy cow!
That gets us into that gets us into the slip ring replacement realm. So think about things that are rotating, machines and robots that have rotating joints, machines and robots that have things that plug and unplug, that are maybe modular machines or conveyor belts. These near-fi couplers are going to be great options for those applications. So more specifically, we'll look at a robotic arm like I mentioned earlier. So some robotic arms in factories, they're going to be versatile, and they'll have like a whole rack of different tools sitting next to them. And depending on what's on that manufacturing line, that robotic arm is going to be, maybe welding in 1 minute and maybe having a gripper arm, the next minute. And depending on the task, they'll just pick up a different tool and perform that function, and then set that tool down and then pick a different one up and do that. And typically traditionally how that robotic arm does that is it transmits power and data to that end effector tool through a pluggable connector. Well, near-fi can replace that pluggable connector. And the benefit there with near-fi is that you can mate and unmate an infinite number of times because there's no contact. With connectors like that, with the pluggable connectors, you're going to be concerned of over time them getting dirty, them wearing, them bending, breaking.
Right.
Make sure they're perfectly aligned.
It becomes another maintenance point.
Absolutely. And maintenance is a huge thing with these near-fi couplers, that it simplifies the maintenance. You don't have unplanned downtime. And I'm sure everybody, all of your listeners are big fans of unplanned downtime. It's our favorite thing when
everybody loves unplanned downtime. You look under your chair, you've got unplanned downtime.
Absolutely.
Somebody somewhere is making a code change that they shouldn't right now and leaving for the weekend.
Yep.
Mm-hmm.
So did you already touch on this? But what's the IP rating of the device?
Yeah, they're going to be in the IP66, 68 range. I'd have to verify that, but it's either 68 or 67.
Okay.
Yeah, so they are.
So that's full dust shielded right there. That's awesome.
Mhm.
Dust and,
So maybe
and
not,
main moisture.
maybe not transfer power underwater.
Yeah, they have not been tested underwater, so that is not a recommended use case for these devices.
Well, the
Just keeping
little
the housing
mermaid's
is
gonna
cool.
be pissed.
Yeah, they can tolerate weld. They can tolerate some weld sparks and things, and some washdown type situations. But yeah, submerging these in water is not recommended.
Have you seen? Yeah. Have you seen? I mean, that it probably. Yeah, that's probably a nightmare to even think about. Trying to. Somebody's going to want to do it. Have you seen any like testing with like dust or like material buildup on these? I mean, I imagine that would just end up being like a PM thing of, clean them off occasionally just to keep the surface clear.
Yeah, I have not seen testing myself. I do know that these another interesting aspect of the near-fi couplers is that they will work through non-metallic substances. So that also
Really?
gets us into interesting things like clean rooms, whether it's pharmaceutical or semiconductor, where you're worried about dust and wanting devices to be in kind of sealed enclosures so there's not friction wearing things down and whatnot. So you can transmit through wood and plastic and glass, but if you try to transmit through metal, you're just like any other wireless application, you're going to run into problems. So.
Well, while you've been talking, Justin's been busy throwing out YouTube links for nearfi examples. So I will be sure to add those to the show notes when we publish.
Yeah.
Uh,
Oh,
I'm,
weld's better.
I'm anxious to look at those myself.
I'm having flashbacks of when I used to pretend like I could weld.
I had one materials class in college, and I got to do some different welding, which was kind of cool. But
Yeah,
unfortunately, they didn't let us do explosive welding, which would have been a lot of fun. But
yeah, I did like studio art in college, and I welded this thing on, and a piece of it came loose because again I was pretending like I could weld, and I covered it in some sort of like canvas thing, and I was like, oh, I can just tack this real quick, and then just the whole thing like caught on fire in the parking lot. It was,
nice.
it was pretty embarrassing.
I think the goal is to not catch on fire.
Speaking of fire, I mean they did let us cut metal with an acetylene torch as for one of the labs, so that was fun.
Awesome.
Yeah. Too bad lighting stuff on fire is so much fun. Anyway,
We all have a little pyro in us.
a little bit here and there. Well, and I guess that's kind of what would happen if you try to use these underwater. But
You keep the housing cool. I mean,
I could see that. I mean, that especially stuff like Justin put that transmitting through plexiglass, but that might be kind of cool for something like entertainment or like themed stuff where it's like you need it to have a certain kind of fascia on it, but then as it mates or something like that, then you can still achieve that communication through it.
Yeah, on the topic of entertainment, I do know in Europe the passenger trains are much more common there. It's a much more kind of matured industry there. They are working on a project now there's an increasing demand for entertainment systems. So the like the TVs, the screens that are in the back of the headrest, like on an airplane, that sort of thing on these passenger train cars. But the physical couplers that are connectors that are currently connecting those train cars, they don't have the physical pins available to handle that increased data usage. So
that's cool.
They are looking to use these near-fi couplers as a potential solution for that to kind of help handle that.
That's cool. I never thought about that. That's
it's kind of interesting because when Scott texted me like, hey, check this stuff out, Justin just sent me some information on this, like within 5 minutes, one of the actual like engine, the controls type engineers in our company had messaged me about a project that I think you guys are talking about it, but about a potential application for this, and it's kind of touching on that same like themed entertainment kind of application. So this is pretty exciting.
The CWNP Wireless IoT Track is the only certification program available that not only covers wireless IoT protocols in common use, but IoT as a technology and solution that is revolutionizing industry and business at the same time. When you work through the IoT track, you learn the protocols, the devices, the data, and the applications that bring the true value IoT has to offer. And for those with the tenacity to persevere, the world's elite IoT certification completes the process and the certified wireless IoT solutions expert credentials. If you want to be in the cutting edge of what's happening in technology, you won't find a better certification program for the Internet of Things.
I mean, one other place that I've seen, you think of your traditional like AGV, AMR in a warehouse, or moving material back and forth, taking it to a loading dock back and forth. And I've run into a couple customers' applications in the past where, again, you have the whole conversation about it's the IT's Wi-Fi. We don't want you touching our Wi-Fi. It's a security risk. We can't put you on it. So instead of connecting the AMR AGV to the Wi-Fi, when you get to the loading dock, they have pedestals there for the unloading, the loading. Hey, here's material came. Here's your new task. They're talking about putting these near-fi couplers on the bottom of the pedestals. So when the AMR AGV comes up to the pedestal, it connects to that pedestal, and then it says, "Hey, here's what I have. Unload it. Here's my new task. Go get it." So all AMRs are autonomous anyway. They don't need to be connected to a network while they're doing work. So instead of having to try to connect it to the Wi-Fi, get everything connected, get through all the security aspects, they're just going to use these as data transfer devices as these AMRs go from dock to dock, get their new task, and then go out and do what they need to do.
I could see these also maybe having some sort of application similar to like an HF RFID tag, where it's you get it in aligned in the field, and it talks, and then you're not writing and rewriting a tag thousands of times. You can have, like, because I think those have like in the higher end tags, maybe like a 2,000 or 4,000 byte data field that could be exchanged. But stuff that has like recipe changes or things like that, like this could be really interesting in that.
Yeah, it's interesting you bring that up. That is another one of the kind of key applications that we kind of promote with this is tracking work pieces, whether it's you can ID the product, the product that's being manufactured like you're referring to, or you can even implement that into the testing phase of the manufacturing process. So maybe you need to test fittings or something, maybe pump air through the machine that you're building, whatever it is. Because the near-fi coupler is transmitting data and power, it can help handle some of that. Some of those.
Yeah, or even maybe something where it's like you have like various test stations that that like an engine or an air compressor, whatever it is, like as it goes through those various test stations, it could couple into that system and then transmit. So are these devices kind of like a linked pair, or is it kind of there's like a hardware ID, and then in your system as they connect, it can go, one receiver can go like station to station.
Yeah, that's a great question. There, as long as you're looking at the same type of device, so like the power only or data only or power and data, any base can communicate with any remote or power any remote.
Nice. Okay.
Depending on what it is. So they just have to be the same kind. But then, the couplers themselves, they have no idea if they connect it to remote pair 1 or 2, 3, doesn't matter.
Interesting.
That's so cool, man. Yeah, and the more I sit here and think about it, especially when you're talking about rotation and things like that, it's the slip ring replacement alone in dirty industry. I could see a lot of different applications for that, especially with like radial cranes and radial stacker reclaimers, because again, they've got those slip rings that's pulling a crap ton of power, but you could replace the slip rings that transfer data with a contactless data, and that would be because that's a pretty big deal when you have to get in there and replace slip rings, because you have to dig deep to get in there to them. So that's extra downtime when you have to do maintenance on those things.
And even more generally, I mean, anywhere that you have a multi-pin connector, right? I mean, you see those circular connectors on machines, or even the rectangular, connectors going inside your control panels. Anywhere where you're constantly going to be unplugging and replugging things, eventually you're going to wear it out, like Danny mentioned earlier, or you're going to turn it to wrong, just a millimeter to the right, and you're going to bend that pin, and now that connector can't connect. So anywhere you're doing that, connect, unconnect, disconnect, this is a great thing to kind of just evaluate and see maybe it fits and can replace that unneeded downtime or uncertainty of data flow.
Yeah, and it definitely seems like it can help you kind of bypass some of the environmental conditions too, especially if, since it can transmit through, like non-RF blocking materials. So
wireless power, that's still, I've been thinking about this for days. So, I mean, again, it fascinates me because just that whole concept.
Scott's thinking about how he can set this up to like do a phone charging and internet for his iPad in his bed.
I'm like, how can I integrate this with the dog? I don't know.
Yeah, you're like telling your wife, like, no, trust me, like it's better this way. Like,
it's industrial. It's industrial. We have one already, but this is industrial.
I mean, if your Wi-Fi is spotty, I mean, this might be maybe this is a feasible option. I mean, only get 100 megabits, but it's better than no Wi-Fi.
I mean, that's a lot of people's whole house internet's under that. So,
or if latency is an issue, I mean, because the latency is down at it's not at 1 microsecond, so it's you can technically say it's faster than 5G in that regard. So,
yeah, and I was actually going to ask. That was my last question was what kind of data latency do we have when transferring data across that? And you're saying it's down to the microseconds.
Yep.
That's incredible. So for those who are not familiar with microseconds, that a microsecond is less than a millisecond. So it's incredibly, incredibly fast.
Yeah, I think 5G that projects to be what, like 1 millisecond is maybe sub-millisecond latency is what they get in the labs and the testing, but just for comparison.
That's incredible. It really is. So as we're looking into some of these other non-802.11 protocols and whatnot, one of the other things that I've always found really cool in just working in industry in general was wireless I/O. And for those who are not familiar with what I/O is, I/O is short for input output, and it refers to the systems and devices that enable communication and data transfer between industrial equipment, specifically control systems and computers in manufacturing and automation environments. I/O plays a crucial role in monitoring and controlling and managing all of these industrial processes, whether it's process automation, batch automation, discrete automation. All of it, relies on I/O for all this data coming in and out, right? This communication is pretty much at its most simplest form, electrical impulses, right? But it's not really encoded like Ethernet data is, because you're looking at either analog or digital signals, and the analog signals are usually like a 4 to 20 milliamp, and 5 milliamp means one thing, 15 milliamp means something else. And it's really interesting how all of that is configured. But really the wireless I/O is the same thing, with the exception it's not backhauling across solid core copper or fiber. It's just backhauling across a wireless medium. Now, you guys actually have some really cool wireless I/O devices that I've played with, and we're actually deploying for a client currently. But there's the big differences with these guys is these are not 802.11, and they're not 802.15.4 either, right, Justin? They're kind of like I would say homegrown, but it's a proprietary protocol. But when I've dug into it, though it's proprietary, it actually is pretty similar to 802.15.4. So I don't know if you guys actually kind of based it on that structure, but looking at some of its capabilities, it seems that way.
Yeah. So, I mean, we've been in that wireless I/O realm for longer than I've been at Phoenix. But what we do is we don't use anything Wi-Fi based. We just try to stay out of that spectrum. There's so much going on there already. Partly because of that, partly because a lot of the applications we work in, or like you mentioned, process automation, we're looking at longer ranges of transmission here, not, this typical 100 feet, 200 feet. We're looking at, thousands of feet or miles. So what we base our communication protocol is a proprietary frequency hopping spread spectrum algorithm, which is similar to what you would use for Bluetooth. So we take, depending on what part of the world you're going to be working in, here in the US, we use the 902 to 928 megahertz range, and we take that spectrum area and we have a proprietary frequency hopping algorithm that we use to hop and send data. So we have that 900 megahertz. It's unlicensed, so we're 1 watt and under. And then we have, depending on where you're in the world, we have versions that do a frequency hopping algorithm on 868 megahertz for like Europe, 2.4 gigahertz for worldwide use. Even in Australia, in Japan, we have specific versions that have the frequency spectrums in there. It's like Australia, they use a 902 to 915. They don't use the whole 28 megahertz
that's
spectrum.
interesting. I didn't know that.
Yeah, for the unlicensed band. So we actually have a model specifically for Australia that cuts off the 902 point or 915 point X up to 928 that only uses that 902 to 915 megahertz for them. So yeah, we internally developed the frequency hopping algorithm, and a lot of people don't know this. We actually built the frequency hopping chip in-house. So we actually developed it from the ground up, developed the actual hardware chip in-house too, which was kind of cool at the time when we did it.
Well, yeah, that gives you really unlimited control if you're developing the actual chipset for the radio. So you're using a proprietary frequency hopping. So there's a lot of different mechanisms within frequency hopping. So I'm assuming, and please correct me if I'm wrong, that you guys, in a similar fashion to like Bluetooth and some of the other frequency hopping standards, you have like different checks and balances for being able to survive in overloaded areas, so that you have like channel blacklisting abilities, various, and I'm assuming like some FCC going on there, error correction.
Yeah, so the beauty of frequency hopping in general is it's built to work around high interference areas. That's the whole point of it. So we have, again, it's proprietary. So depending on the data rate that you select within the radio, it has shorter or longer dwell times on the channels. It will retry, so if it sends out a packet and it doesn't get a response that someone received it, it will retry a certain period of time, which is configurable in the radio as well. And then you do have the ability, again, depending on how big your channels are and the FCC rules, to blacklist, whitelist channels in 1 megahertz, size as chunks. So hey, at the lower end of the band, you have a lot of licensed stuff. At the top end of the band, you have a lot of cellular. So again, when we run into situations where we're in like metro areas where there's a lot of, again, cell towers, private stuff that's really, really high power, and we're working around it. Sometimes the energy in the area is just too much, and we have to block those frequencies, not even try to use them. So those functions are available within the platform to make things more reliable. But generally speaking, again, Danny coming in we released this product 2014, 15. In the 10 years it's been around, I very rarely have asked people to block frequencies. It's just the frequency hopping algorithm in general, not just ours, but how frequency hopping works in general, is built to just coexist with other systems.
So because you've got just below 902 is cellular, just above 928 is cellular, so it's all licensed, and it can, especially if you're closer to a tower, it can definitely bleed over whether you like it or not.
Where we run into and where we work a lot is water wastewater. So what's the highest area in area where you have water wastewater?
Water towers.
Water towers. And what's on a water tower? Cellular antennas. So yeah, so it was like we talked about back in episode 1. There's a lot of that. Let's plan out first. Let's make sure we know it's there. And again, if it's installed correctly and everything, it's very, very reliable. And again, distance wise, again, 900 megahertz, 1 watt. You're in low band at a quote unquote high power. I mean, you're going miles if you have a good shot. We did a project years ago. I think it was down in Arkansas. It was mountaintop to mountaintop. It was 10.8 miles. Just passing IO data back and forth. Just taking a signal of a float from a tank and sending it back to a SCADA system.
That's absolutely insane when you think you're wirelessly passing IO data 10 miles. That is insane. Now, granted, I realize you have to set certain refresh tolerances in your controller, but what kind of latency are you looking at for a link that long for I/O?
Yeah, so again, it depends on a lot of things, but like if you're putting us in a vacuum and just looking at the raw specifications of the radio, it depends on the data rate. So it's configurable channel sizes, data rate. Um, the fastest data rate, which is like 500 kilobits per second. Again, we're sending I/O. We're not trying to stream Netflix or
Yeah,
this thing.
absolutely. You're not trying to watch cat videos on YouTube.
Nope. We don't need data instantaneously. Um, our dwell time can be as fast on any hop can be about 16 milliseconds. So it's fast.
That's very fast,
Yeah, and if you're
especially
just
for 900 megahertz.
yeah, and again, what are you looking at? Too? You're looking at, I have a flow sensor on a 1 million gallon tank. That's not changing very quickly. I don't need to have that data instantaneously. I'm turning on a pump to fill the tank back up. As long as it turns on in the next 30 seconds or so, I don't really care if it takes 2 seconds or 5 seconds. So that's what it's built for is more of your monitoring of those I/O signals, those non-critical control, non-latency focused control, and there's tons of them. You think in water, wastewater with lift stations, tank levels, flow, just monitoring the flow in general. Oil and gas. Just monitoring how much gas is coming out of the ground, turning on and off drives and pumps. It's non-critical control, and we live in that area with this technology.
I think that's a great way to explain it is non-critical control. That's probably the best way I've heard that explained like ever, because that gives you a lot of flexibility for all of these things that you need to have this data from, but it's not mission critical for the process to continue operating in most respects.
I remember years ago when we first launched it, if you talk about non-critical control, I got a call from one of our sales guys down in Texas, and they had already done it. He was just calling to tell me because it was a really, really unique application where they had this, I don't remember what town it was, but they had a rodeo, mechanical bull that they had for this rodeo that they did. And they used this product to tell the mechanical bull what function to do. So, kick or jump or whatever. So it was literally, again, non-critical. Spin a little faster, kick a little harder. It actually controlled the mechanical bull at this rodeo, and you had people sitting on it getting thrown off a mechanical bull. It was kind of funny.
That's awesome.
My body's just hurting just thinking about that.
I wish I had a video of it. We wrote it up as an application note, but I never saw a video of it. That was one I wish I would have seen firsthand.
I bet that would be a hit at a trade show.
Oh, that's a good idea.
Oh, that would be
probably a liability nightmare, but
they could make people sign waivers.
Waivers,
it's all good.
The waivers are for, right?
The waiver fixes everything.
Get a physical therapist to sponsor the booth.
Oh, man.
That would be awesome. So, and kind of following the vein of what we were talking about earlier, what are general use cases that we see for wireless I/O? Really kind of spans across the spectrum. Where I see the majority of it personally, like I say all the time, the majority of work I do is in pulp and paper. Most pulp and paper facilities have their own water treatment facilities, and that's typically where I see it because it's large distances. They need to get that environmental data. Though that environmental data is important, it's not critical to running the process. So, if it takes 20 to 30 milliseconds, it's not hurting anything.
Correct. And again, being down in that 900 megahertz spectrum, you're going to be able to penetrate. You talk pulp and paper. I mean, there's a lot of absorption in your areas. I'm not saying you're going to get through everything, but you're going to get through things unlike you do with Wi-Fi. So maybe you'll get through one or two stacks of paper, but the radios can repeat through each other, so you can use that to go around those obstructions. And again, 900 megahertz is just so robust. Adding the frequency hopping, we did some testing years ago on a shell refinery down in Houston. With this thing can't go through our environment. We have tanks and walls and stuff. We put a radio in an office, put it on a battery, started driving in a truck. We got through 6 of their 1 million gallon tanks and a blast wall before it dropped out. We weren't far away. 100, 200 feet, but we're behind 6 tanks, and then we turned behind the blast wall, and then it finally clicked off, and we got behind the blast wall, which I was pretty okay with. The blast wall can keep us from getting hurt from a oil explosion. I'll take that.
I was doing an assessment for an ore processing site out in Tennessee, and they were wanting to know how Lorway would do out there because there's a whole suite of sensors they wanted to get, but they didn't know how to test how 900 megahertz would do, punching through all these gigantic areas they have that are just full of pipes and chemicals and all this other stuff. So I took a pair of the RAD 900s out there and started putting them in different control rooms. And I was able to fully test 900 megahertz penetration through that entire site. And it was fantastic.
That's awesome.
So while I don't know what all wireless IO is not created equal, everybody has their own way they do things. But I can definitely vouch for the validity of penetration that you can get with those particular radios. And I am a big believer in them after seeing firsthand what they were capable of punching through.
Yep, and that's a big differentiator. So one thing, again, I still today, but when I was doing the wireless job for a while, one of the questions always is what makes every 900 megahertz IO radio different, right? And that's the big thing. So I said before, we developed our own chip. So nowadays, like, the name of the game is let's get things done the quickest and most cost-effective way we can do it, right? So cost-effective has its trade-offs, right? So we use physical amplifiers and noise rejection components on our chip to make sure that when we see interference, when we have to amplify our signal to make it go further, we have hardware pieces to do that. That stuff kind of costs a little more money, even though it's little PCB board components. When you add it all up in the end of the manufacturing process, it adds little cost to it. A lot of the people we see in the same realm use software-defined radios to do that rejection and amplification. So when that next level of coexistence or interference or noise comes into play, we tend to, and I don't say it's everyone, but in my experience, same to you, Scott, did it for so long and I've seen it, we tend to perform a little better because we took that little more effort in the beginning to put that engineering in on the radio chip itself. So, if you're looking at using 900 megahertz IO in the future and you're looking at the cost of it, you may want to talk to the supplier that you're talking to and go, hey, what do you use for noise rejection? What do you use for signal amplification? What do you use for interference rejection? How do you build that on? How do you do that? On your hardware, and see if they have some more information on how they do it. If it's software based, you may see some different performance than if you see if it's hardware based.
We've definitely, not in this specific technology, but we've definitely worked with some vendors before, and they believe everything can be fixed with a firmware patch, and it's like, okay, man, you can, in some instances, like, yeah, you can mask a lot of stuff with software, but that's good to hear that, because it is really, like, at a certain point, like, you get the ability to cover in software plus having that hardware component.
I mean, people that are audiophiles, that's a big debate, right? You got digital versus analog, and
that's a good YouTube rabbit hole to go down, where the people are like, oh, it's this such and such gold plated, whatever, and like you can really hear it, and then you got to make sure that you've got a humidifier that has ionized water. That's like I'm like the same way with coffee. When people are like, oh, the AeroPress, it's you could tell. I'm like, I can't taste the difference in any of it. Like, what's going to get me there?
You better be careful there. Coffee's a big topic.
Well, all attention is good attention, right? So even if we can get some hate listeners too, that'd be fine.
Any publicity is good publicity, right?
He said what? And my email is scott@industrialwifishop.com.
Yep.
I was listening to another podcast the other day. It was a true crime murder podcast, and they mentioned the little girl said something about crocheting and how she hated it. She's like, no, I'm just kidding. Oh, I just alienated half our viewers.
Oh yeah.
Well, I think we're fortunate. I don't think we have very many crocheters on the listening list. So I
Hey,
think
you never know, man. They might be thinking about ways to do the a crochet cover for their new Nearfi device.
well, Jeremy, if you're I know you crochet your own underwear, but that's a whole different podcast that we'll have to get into at a later date.
Hey
Yeah,
man,
yeah.
I don't yuck anybody's yum, man. Whatever you like to do.
Hey, instead of having your cargo pants, you could have your crocheted patch on the side.
That's right.
Okay. All right. I gotta get this off my chest. You talked about the cargo pants and how your cargo shorts and you just kind of gave it up and went and got some. No. When you become a dad, it is law that you have to start wearing cargo shorts. That's just how that works. You don't have a choice in that. They magically appear in your chest of drawers with all your clothing because now
The
that you are
stork
a
drops
dad,
off a pair.
you have to wear cargo shorts. That's just how it is.
They'll show up before or after the white New Balances.
Let me tell you, man, there's no finer pair of shoes on the planet.
Than a pair of white New Balances. Yeah.
I got some crisp ones for my talk for WLPC.
I haven't gone to the high socks yet. I still, I have the cargo shorts and the white New Balances, but I don't have the high socks yet.
I
Yeah.
actually just checked. My shoes are New Balances. They're just not white.
Nice.
You got your lawn pair on.
Right. Yeah, it's my yard pair.
To kind of get back on, so this is, in these devices that we just discussed, I know that, there's some kind of common use cases, but have you seen any kind of exotic applications of this stuff where people kind of, I don't want to say abused, but kind of like teased, like a boutique type use case out of them?
Sure, I have.
I think a mechanical bull is kind of an
Well,
an
yeah,
outlier.
I'm trying to think of something that's.
Because I'm just thinking, sometimes we run into stuff and it's like, okay, well, at some points, 900 megahertz is susceptible to interference. Have you ever had any applications where people use like a redundant system, like had like a parallel system of these or anything like that?
Yeah. So we have worked on a couple of those. There was one down in Atlanta a couple years ago where it was a water filtration building. So all the filters to cleaning all the wastewater. And the requirement was, they wanted to put radios on all the pumps to monitor, the torque, the bearings, everything. So if it was getting higher current, they could maintain it, the filter, whatever. But, big question, well, how do I know if that radio dropped off? How do I know if the whole system dropped off? What happens if the main radio goes down? What can I do? And yeah, what they did, they couldn't have multiple radio systems on the same network. I was like, right next to each other, obviously they would interfere with each other. But we ended up coding into the PLC. There are signal strength. So with the IO radios, you can do IO in and IO out just to send a signal, or you can take that IO data and convert it to Modbus at the main site to take into a PLC. So you don't have all the IO modules you would have for ins and outs. So when you do that Modbus mode, now there's a register for all the signal strengths of all the radios. So you can pull all that data and go, hey, radio 1 signal strength is X, radio 2 is Z. And then there's also a signal strength register for the main radio, which is typically invalid when there's multiple radios connected. But if we're to lose connection to all of them, that value goes high. There's like the 255. So what they were doing, they were monitoring that value of the master radio, and as long as it was 0, which meant it was connected to something, it was fine. But if it went to 255, they go, all the radios disconnected. They would start a timer, wait 2 or 3 seconds. Okay, the main radio must be dead. Power it down, power up another one that's programmed exactly the same, kind of like a cold standby. And it would let the power up back up, and then all the radios would relink to that new one, power down the other one, and then they would have an alarm that would email out going, hey, we just transferred power to the second radio. Something went wrong with the first one. So they'd have an alarm so someone know that backup radio is now the primary radio, and they should someone come out and check on it.
Yeah, because that's stuff that we run into a lot is it needs to be, because sometimes it's like, okay, well, if we don't get the transmission of what's this temperature sensor, if we don't get it for 10 minutes, that's not necessarily a big deal. But some things have kind of a tighter window of needing that information to be, available. So that's pretty interesting. I like that's the kind of stuff that I like because we always have weird customer requests.
It was definitely when we worked through for a little while trying to think of the best because they required some kind of hot standby or cold standby, and it took us a little bit to think through the best way of doing it, but it ended up working well, and it's been installed for 8 years now. It's been running well, so.
So all of that was just coded into the PLC, and that's telling when to cut power to one and power up the other.
Yep, it was looking at a data register in the radio, going, "Hey, as long as this value is X, we're good. If it goes to Y, then we know that we lost link to everything in the field. There's no longer any connection to any of the filters. Cut power, turn on power to the other thing." So, yeah, that was all coded as ladder in the PLC. And they were able to, yeah, just use that as a kind of a monitoring task.
I'll raise my hand and ask for the people like me that don't use Modbus a ton. Is that something you could maybe kind of give us like a little 30, 45-second explainer of what that is?
Sure. Yeah. So,
And don't tell Scott I said that because he'll judge me.
He was looking at me the same way. He didn't know what it was either. So yeah,
but he probably successfully played it off like he did know, and then he went and looked it up after he talked to you.
I saw him typing, just Googling. So yeah, Modbus is an industrial communication protocol, a language. Other ones you may hear, Ethernet IP, Profinet, EtherCAT, industrial communication protocols that the PLCs use. So Modbus specifically is a poll response-based protocol. So the main controller's SCADA system will request out for some data. Hey, Scott, tell me your name. Where you live, what your address is. It'll sit there and wait until Scott responds. It'll go either A, Scott didn't respond, I'm going to try again, or B, Scott didn't respond, I'm going to time out and go to the next thing. And then it'll go, hey, Jeremy, what's your name? What's your address? How old are you? It'll sit there and wait. And it'll just do that over and over again based on the code. It's been around for a long, long time. And it's very, robust, reliable protocol. Not the fastest, but again, in a lot of things that we work with the wireless I/O, it doesn't need to be fast, so it works perfectly. It's very, very deterministic and robust, and again, it's very known to a lot of PLC programmers, SCADA systems. It's pretty common.
Yeah, reliability. There's a lot to be said for the reliability aspect, and that typically is more important than anything else. So,
and that's where that's that's like it's a different kind of like cabling too, right? Like it's like a shared. Is it like a shared medium?
So it's more just a language. So I mean, you can do it over serial. It's Modbus RTU, or Modbus TCP, which is over TCP Ethernet. Again, in industrial world, it's very common. So if you look at like an Allen Bradley control system, you're going to hear Ethernet IP or DeviceNet as a serial protocol. If you look at Profinet from Siemens, it's going to be Profinet for Ethernet, Profibus for serial. And then the back office of the world use their EtherCAT protocol. So those are the four main ones. There are some other things that are around, but those are the four main ones used in an industrial space typically.
No, thanks for that. I appreciate that. I work around it all the time, and I hear them thrown around all the time, but actually understanding more about them is, I'm too busy doing other things to really spend the time to understand that.
Sure. Yeah. It's important. It's important because like we talked about before, like IT/OT is merging, again, these protocols aren't overly known on one side versus the other. So like if the OT side knows them really well, the IT side is learning them. So it's important to know that they're there. And when you hear the terms, know it's a normal thing or it's expected.
With like the RADs themselves, are they transporting actual Modbus? Is that what they're the data they're transporting for the I/O, or is it something a little more proprietary?
So the way the I/O to Modbus function works is we're just taking the raw I/O data from the field, sending it over the air to the main hub, and then it's being stored in a table there, in a preset table. So then whatever wants to read from it just goes, hey, Modbus radio, give me this data in this location, and it pulls that raw data out of there. We can send actual Modbus over the serial ports. So if you have a serial-based Modbus device, we can send
Okay.
that Modbus packet over the air too.
That's interesting.
Yeah, so like where we see that a lot, again, there's a lot like water wastewater is a ton of old serial based PLCs that are out there that we call it the man in the truck. Every 8, 12, and 4 every day they drive out to a tank, they read the meter, they write it down, they go back in. So what we'll do is put radios out there on those serial based PLCs and just wirelessly connect them back to a main hub or the SCADA system. Well, now that person who's driving around 3 times a day can go do something more effective for the process versus having us to drive back and forth.
And he's probably pretty pissed off because he enjoys his daily drive because he doesn't really have to do anything else.
Yeah, I've been around some of them that weren't very happy with me. No, yeah, it's been there.
Well, that's usually when we're doing like AGV jobs. You try not to tell the forklift drivers what you're there for, so that way they don't, decide today's their last day of work for that company or out of jail.
And all of a sudden, their hit knots mysteriously stop working.
They're like, hey, you look kind of like an access point hanging off of a pole. I'm gonna just run you over.
Yeah,
I cannot tell you. Sometimes I really think it's open season on wireless devices for pit drivers. I really do. It's nuts. Well, fellas, I cannot thank you enough for coming on and telling us a little bit more about just really cool wireless technology that we get to see and play with in industry and manufacturing. It has been a great time. I have really enjoyed this, and I think our listeners have too. Any parting thoughts from anybody?
Well, Danny and Justin, do you guys, if somebody has questions about this technology, what's the best place to reach out and inquire about it?
Yeah.
LinkedIn?
Yeah,
Phoenix
LinkedIn
contact,
or even my
Bat
email
signal?
address. Yeah.
bat signal. Oh, bat signal. I think pretty cool. Wireless bat signal.
Yeah, we
We
should
can
have
do
LinkedIn.
smoke signals, semaphore, with flags, communicating with flags.
A bosun's whistle?
Yeah, no, LinkedIn is a good place. So
Okay,
just
cool.
reach out to me on LinkedIn.
And for me,
Okay.
LinkedIn. I'm sure Scott's going to put our contact emails in the email. Again, my role now is more in the field. So if you're in we call a Metro Mid-Atlantic, so the New Jersey, Pennsylvania, West Virginia, Maryland area, be happy to get together with you and talk automation, talk wireless. Happy to do that. I cover the whole area. Great to meet you guys if you're in the area.
Yeah, so I'll put everybody's contact information in the show notes, and including personal phone numbers and addresses, and it'll be a good time.
I'll give you my Google Maps screenshot too.
Okay, awesome. Well, we want to make sure everything's targeted specifically, so we're in good shape. Well, guys, thanks again. I really appreciate everything, and have a great rest of your weekend.
Thanks, Scott. Thanks, Jeremy. Thanks for having us.
Thanks, guys.
Thanks,
See you in
guys.
class.
Thanks for listening, everybody, and we hope you join us on our next episode of the Industrial Wi-Fi Shop.